All right, we are going to go over logarithmic rules today. There are three particular rules that we will use on the ACT, and that is the product rule, the quotient rule, and the power rule. These are listed here, and it is a very straightforward methodology here. So the product rule means that you can take the log of two numbers being multiplied and you can split them with addition. And vice versa, you can go backwards. If you have a log or if you have two logs with the same base, in this case base A, then you can combine them via multiplication, hence the product rule. Um, if the product goes along with addition, then the quotient rule goes along with subtraction. Only makes sense. So if two numbers are being divided, or two values are being divided inside a logarithm, you can break them apart with subtraction. Same way, if two logarithms are being subtracted with the same base, then they can be divided, brought together by division. And then the last rule is what we call the power rule. The power rule allows us to take an exponent inside of a logarithm and carry it down to its coefficient. Okay, so ideally what you're looking at here is if you had something like this, log base 3 of x raised to the second power. In this case, our exponent is 2, so 2 will become our coefficient. So 2 times log base 3 of x. These are equivalent statements. And just the same way, I could take the 2 and I could push it into the logarithm if I wanted to as an exponent. So again, it drops down to multiplication, but it becomes exponential. So let's do a few problems here. The first problem here is log 10 times x. Well, again, this is being multiplied. Note that it doesn't have a base, which means that its base is 10. This is what we call a common logarithm. So I can separate these using the product rule. So with the product rule, I can take this and I can break them apart or expand them. Log of 10 plus log of x. That is the product rule. I just broke them apart. The second one we have here is log base 4 of 4x squared. So the way I would approach this one is I would actually break them apart first with the product rule. So the product rule tells me I can make this log base 4 of 4 plus log base 4 of x squared. Now, we could simplify the log base 4 of 4 because this is asking us 4 raised to what power is 4? Well, 4 raised to the first power is 4. So technically, this can simplify down to 1. Plus, and then here we have log base 4 of x squared. That is a power. So we will use our power rule here. The power rule allows me to take the exponent and drop it to my coefficient. So this will become 2 log base 4 of x. Here, we have the natural log. ln is what we call the natural log. We have the natural log of x times y divided by z. So again, we can just start breaking this apart. Anything being multiplied should be added together. Anything being divided will be subtracted across. So I'm going to first do the quotient rule here. And the quotient rule tells me that I can make this the natural log of xy minus the natural log of z. Okay, and then from here I would do my product rule because the only things still attached are the x times the y. We will apply the product rule here. The product rule tells me that I can break these apart. Natural log of x plus the natural log of y, and then we didn't do anything to the minus natural log of z. And that would be the final result here. All right, let's look at this a little bit more. In this case, we need to condense. So condense means we want to bring it all together. They are being subtracted. They have the same base. They're both the common logarithm. So I know that I can use my quotient rule here, because the quotient is how you bring together two logarithms with the same base that are being subtracted. So I can bring these together as log, no base, 7 divided by x. 7's on top, x is on the bottom. That would be the condensed form of it. Same way here, they're all stretched out. We have addition, which tells me product. We have subtraction, which tells me quotient. So they all have the same base, base 2, base 2, base 2. So I can combine them. Log base 2 of 5 times x, quotient rule applies, divided by 3. And that is the condensed form. All right, let's do 2 more, a little bit more complex. So we have 2 log base b of x plus 1/2 log base b of x plus 4. Since we're going to condense here, we actually want to handle our coefficients first. We want to use our power rule here. So the power rule tells me that I can bring these both into exponents. So we're going to do that. We're going to have log base b of x squared plus log base b of x plus 4 raised to the 1/2. Note here that anything that's raised to the 1/2 is also just the square root of the same value. We could use that here if we wanted, but we're not going to. Now from here, the only other thing that we have to combine these is we have the addition here, which tells me product rule. So the product rule tells me that I can multiply these together. So I will have log base b of x squared times x plus 4 raised to the 1/2. It looks kind of funny here, but again, it can be listed as that. We could probably simplify a little bit further, but at this point, I'm just trying to emphasize what the rules are and how to use them. Because we could take a square root, but we can't really distribute the square root. So this is good enough. All right, last one. Same thing, right? We want to deal with our coefficients first. So let's use our power rule. The power rule tells me I can take the coefficients and put them inside of these. So we're going to have log base b of x plus 2 squared, or not squared, raised to the 4th power, minus log base b of x minus 5 raised to the 3rd power, since that was our coefficient. And then from here, we have subtraction, which says use the quotient rule. So we can divide them. So we have log base b of x plus 2 raised to the 4th divided by x minus 5 raised to the 3rd. We would be taking the logarithm, that whole thing. So that would be our final result. So you have homework to do with this. Go through the CUDA worksheet. Answers are provided, so check yourself.